Hello math people, Mr. Ray here with another lesson, grade 10 academic math. So this will be our next lesson in multiplying binomials in our first quadratic unit. Okay, so this is a fairly short lesson compared to last. So a couple terms here, should remember what those are. Trinomial is a polynomial with 3 terms, and a binomial is a polynomial with 2 terms. And now we have a couple of new things. We're going to actually learn 2 special multiplications of binomials that give the result will be either a perfect square trinomial or a difference of squares. So there's no point in explaining this until we get to it. You can see where it comes from. Now, we're going to be covering this in a second, so let's just jump right in. So we're going to learn 2 special cases. So let me just show you what those 2 are. So we learned how to multiply 2 binomials last lesson, and that technique won't change, but we're going to learn about 2 special cases. The first one is, well, what if you multiply the same binomial by itself? So I just got some variables in here to show you the generic form. So if the 2 variables are exactly the same, and we have a special way of writing that, right? If you multiply the same number by itself, we would say, oh, you're just squaring the number. We also do that for binomials or any polynomials. So since we're multiplying this thing twice, or by itself, twice, I guess, we could instead write it to look like this: a plus b squared. So that means you're taking this a plus b and you're multiplying it by itself, another a plus b. The other special case is, well, say you had, your a plus b was your first binomial. What if we just kept the terms the same, but maybe flip the sign? So a plus b, a minus b. Okay, so just to give you a little glimpse at what we're going to do, this is actually called your perfect square trinomial. It's when you multiply the same binomial by itself, and the difference of squares is the one where you multiply a binomial by itself, except that the sign has changed for the second term. Okay, so we'll look at what that is. Okay, now, so maybe we could jump into some examples here. So I have x plus 4 squared. Now, remember what x plus 4 squared really means. Okay, if we work backwards here, x plus 4, in this case a plus b as an example, this isn't the same. I wouldn't just take this and say, oh, that's just a squared plus b squared. Okay, that would be wrong because you're missing out on something. You'll see that in a second. So anytime you see any kind of binomial squared, I want you to write it out like this, so you're not tempted to put just x squared plus 4 squared, which would be wrong. So x plus 4 times x plus 4. Okay, and if you remember, now you can still use your FOIL. So x times x, maybe I'll just do that this time, x times x. Then the outside would be x times 4. Then the inside is 4 times x. And then the last is 4 times 4. So like I said, you don't have to do that step. That's really what you should be doing you're going to be doing in your head. So if we expand this, we get x squared plus 4x plus 4x plus 16. And when we combine them together, we get x squared plus 8x plus 16. So this shows you that if you just said, oh, this is just x squared plus 4 squared or x squared plus 16, that's not right, because there's actually an 8x here. Where did that 8x come from? Well, it came from our outside and our inside multiplications. We got 4x each time, which kind of what you can see here is to get the final answer, it's going to be that squared plus that squared, and then if we multiply these two terms together, get 4x, we double it because we're actually doing that multiplication twice. So that's kind of a, proof that you just can't square each term. That's not right because there's more to it than that. Okay, so let's try this one here. So k minus 5 times k minus 5, which is what we're going to write it out as right away to avoid getting it wrong. I'm going to skip this first step this time. So k times k is k squared. Hopefully the different variables don't throw you off. You have to be ready to see any kind of variable. It's not always going to be x. Okay, so that's k squared, and then outside is minus 5k, and the inside is also minus 5k, and then the last will be negative 5 times negative 5, which is 25. And if we simplify that, combine the two middle terms, k squared minus 10k plus 25. Okay, and again, you could look at that rule and say, hey, I could kind of avoid this FOIL work since it's the same binomial. I could square that, k squared. I could square that, that's the plus 25. But don't forget, if you multiply the two terms together, negative 5k, and double it, because we're actually getting that twice, so negative 10k. So if some of you see that and want to just jump to the final answer, that's totally fine. But if you're not confident with doing it that way, just treat it like a regular binomial times binomial or a FOIL question. Okay, so now let's do one with a little bit more to it. So 3y plus 7x times 3y plus 7x. Okay, so same process, with just now we got a couple of variables and some more coefficients than we had before. So first would be 3y times 3y. So when you're basically squaring 3y, so that's 9y squared. Okay, then the outside would be 3y times 7x. So the number part would be 3 times 7, 21. Now you've got a y times x, so here's an important thing. If you have multiple variables in the same term, put them in alphabetical order. So instead of saying yx, let's just change that to xy right away. Okay, the order shouldn't matter because it doesn't matter, 6 times 7 is the same as 7 times 6, just like xy is the same as yx, but when we're looking for like terms, it's important that you put it in alphabetical order so that you can see more visibly, oh, those two are the same, those two are like terms. Okay, otherwise if it's in the other order, you might not catch it. Okay, so that's the outside. Then the inside, remember the outside and the inside are exactly the same because it's the same terms. So again, we have a 21xy. And then the last term squared, 7x times 7x, is plus 49x squared. And then if we simplify it, we get 9y squared plus 42. So we're basically doubling that coefficient. 42xy plus 49x squared. Okay, so that's we call these remember the word for it, perfect square trinomial, or PST. That's when so all three of these were basically you take a binomial, you multiply it by itself, or in other words, you square the binomial. So the result of what you get here is always going to be a trinomial, 3 terms. And we call it a perfect square trinomial because it's basically you've squared a binomial to get a perfect square trinomial. Okay, this one here is the second case, the difference of squares. And you're going to see where that name comes from in a second. So right now, let's just see what we get when we multiply. Move this line above. Okay, so let's, pretend we didn't even notice they were the same. But you can see that the terms are the same. We just have a minus and a plus between them. So that you couldn't write this as squaring because it's not the same. But let's just go through the FOIL. So maybe I'll do the long way this time. So, or maybe not. Q times Q, that's the first, that's Q squared. And then the outside I have Q times 11. So that's 11 plus 11Q. And then the middle I have minus 11 times Q, so that's minus 11Q. And then negative 11 times positive 11, so that's going to be negative. And 11 times 11 is 121. Now here's the cool thing. The thing that happens all the time when you have a difference of squares, when you have a binomial times itself with the sign change in the middle. These two terms here are like terms, but they're the same number but opposite sign all the time. So these two actually cancel each other out, and you're left with 0Q. So I can just simply write that as Q squared minus 121. And we call that a difference of squares because that's a square, that's Q squared, and this is also a square. So I could actually write this to show you what I mean. That's Q squared minus 11 squared, because that 11 squared would be 121. So this is a difference. The difference in math means, we talked about this earlier, a difference means subtraction. So here's one square, it's Q squared, and we subtract another square, 11 squared. Okay, so this is a difference of squares. So if you see that ahead of time, you can actually take a shortcut and say, you know what? And looking at this one here, you can see it's a difference of squares because 4m, 4m, 3n, 3n, plus and a minus. So you can actually just, instead of doing FOIL, you just do FL. You do the first two and the last two because the outside and inside always will cancel. So this time I'm going to save myself some work and just say I don't need to figure those two out because I know that they're going to cancel each other out. So I just do 4m times 4m. That's 16m squared. And then the last one, positive 3n times negative 3n, that's minus 9n squared. And that's a difference of squares, which I can write as, basically, what did I multiply? I multiplied 4m by itself, or squaring, and then I subtracted 3n squared. So again, a difference of squares. Okay, now in a couple lessons from now, we're actually going to go backwards. I'm going to give you something that looks like this, and you're going to turn it into this. So that's why I want you to kind of understand these special cases. Okay, got a little word problem here. Maybe you're bringing some geometry from grade 9. So we have a circular helicopter pad, and what they've done is they've changed the size of it. They've increased it from some unknown radius to, they've added 3 to the radius. So we want an expression for the area of the new circle. So let's draw a little picture. Pictures always help. So say this was the original helicopter pad. Now in terms of the radius of that, we don't know what it was, so we're just going to call it R for radius. Okay, and then they've increased the radius by 3. So let's just draw what it might look like. So the new radius, I still don't know what it is, but if I took the old radius and I added 3, that would be the new radius. Okay. So if you remember, the area of a circle is pi times r squared. Okay, so they want an expression, simplified expression for the area of the new circle. And we basically said from this diagram, we're just going to use the variable r to represent whatever the old radius was. It might have been 12, it might have been 6, it might have been 30, we don't know. So that's what variables are used for when you're not sure the value of something, or maybe you want to change it. So I'm going to start off with this area of a circle. I'm going to call it, I'm going to put a little subscript here. So the new area, because it can get confusing. You might look at that and go, well, which area are you talking about? Because there's two circles. So the new circle will be the larger circle. Okay, you could put large there too if you wanted to. Now, pi r squared is the formula. So remember, pi is just a variable, 3.1415926. Keeps going forever. We're just going to use pi, so we can use it in our calculator if we have to. But the r is not r. The r is from here to here. So what is the total length from the center to the outside of the big circle? Well, it's r plus 3. So the big circle's radius, or the new circle's radius, we're not going to put r, we're going to put r plus 3 in brackets, and then square that. Okay, we can't just say r plus 3 squared with no brackets, because then you wouldn't be squaring the whole thing. All right, now this is kind of what we just did. We took a binomial and we squared it. So this is the connection back to the previous learning in this lesson. So I'm going to put the pi outside, and just like we did last lesson where we had a constant times a binomial times a binomial, we'll figure out what this is first and then multiply our result by pi. Okay, so when we square it, so remember r plus 3 squared is r plus 3 times r plus 3. Okay, don't forget that already. It's not just r squared plus 9. Okay, it's actually going to be, if we work this out, it's going to be r squared plus 3r plus 3r. So I'll just save myself a line here. I know I'm going to have two 3r's, right? One from here and one, so outside and inside are both 3r's. When I add them together, I get 6r. And then when I square the 3, or 3 times 3, that's a plus 9. So that's the simplified version of that. This is a perfect square trinomial that we got from there. And now we just multiply everything by pi. And pi is kind of a weird animal. It's really a number, but it certainly looks like a variable. It doesn't. But if I'm going to show that here, there's kind of a convention in math. We would almost treat it like, well, you do treat it like a constant. So you put it in front of your variables. But if you have a number and pi, so pi times 6r, this is where you'd probably put the real number first and then the pi and then the variable r. And here you're multiplying pi with 9, so that's just plus pi times 9. Okay. So this is the area of the new landing pad based on the original area. Okay. So second part, this is probably the more interesting part. Find a simplified expression for the increase in area. So by increasing it by 3, how much bigger did it really get in the area? Okay. All right, so again, I'm going to talk about area. So this is like a third area. So the increase in the area that's what we want. That's actually equal to, so if I go back, I want to take the area of the big circle, the new circle, landing pad, and I would subtract the original area. And the difference would be this donut part here, and that will be the area that it's grown by. So that's what I'm trying to show here. So it's the area that's new, the new area, the big circle, minus the old area, or the small circle. Okay, now we already know the new area, we just did that. So I'm going to replace this with pi r squared plus 6 pi r plus pi 9. Okay, now I'm going to subtract. So what's the original area? Well, the original area just used a radius of r. So I can go back to my formula here, and if I just replace r with r, it's really not changing the formula. So the original area was just pi r squared. Okay, I don't have to put brackets around, but I could, because it's only one term. So it's always safe to put brackets if you're not sure. So if you look at this, I got pi r squared plus this minus pi r squared. So these two really canceled out. So the result is just 6 pi r plus pi 9. Okay, so that would, if I actually plugged in the original r value and put this in my calculator, I could actually figure out how many square meters did it get bigger by. Okay, but the thing is, you have to know what the original radius is, because it's going to change based on that. The difference will change. Okay, and this would be, if you want to be really impressive math-wise, the units would be meters squared in your final answer. And that's that. So again, I've got some homework questions. Try as many as you think you need to get the idea of the lesson. And homework solutions will be posted within a couple of days for you to check. Okay. So that's it for today. Hope you guys have a great evening, and we'll see you on the next lesson.